Hi, so in this video we are going to solve a problem where we have to find the smallest number, which is when divided by 3, 5 and 7 leaves remainder 1, 2 and 3 respectively. So in this problem the remainders are not constant, that can be seen, and at the same time the difference between the divisor and the remainder, this is also not constant. So how to solve these kind of problems? Let's forget this problem for the time being. Let's revise one concept. Suppose you want to divide 13 by 6. So if I divide 13 by 6, 6 2s are 12 and I get remainder as 1. This remainder 1 is actually less than both the factors of 6. This remainder 1 is less than both the prime factors of 6, which are 2 and 3. The thing is, if I divide this 13 by 6, I get remainder 1. At the same time, if I divide this 13 by any of these two factors, each time I get remainder as 1 only, right? Or for example, if I take another number, let me take 47. If I divide it by 15, 15 3s are 45, and if I subtract, I get remainder as 2. The factors of 15 over here are 3 and 5, and if I divide this 47 by either 3 1s are 3, 3 5s are 15, or if I divide it by 5, in both the cases again I get remainder 2. So one thing which we can recollect from here is, if the remainder is less than all the factors of the divisor, then if you divide the dividend by any of the factors, you will again get the same remainder. So the same property we are going to use over here, and we are going to solve this problem. So in this particular case, the difference between the divisor and the remainder is not constant. But if I talk about the factors of 3, 5 and 7, yes, they don't have any integer or whole number as their factors, but they do have fractional factors. I can say that 3 by 2 is a factor of 3, which will divide 3 2 times. At the same time, 5 by 2 will also divide 5 2 times, and 7 by 2 is also a factor of 7, which will divide it 2 times, right? So 3 by 2, 5 by 2 and 7 by 2 are factors of 3, 5 and 7, and if I write them in the form of decimals, 3 by 2 can be written as 1.5, 5 by 2 can be written as 2.5, and 7 by 2 can be written as 3.5. And here you can see that all these remainders 1, 2 and 3, they are less than these factors of these given numbers, right? That means we'll leave the same remainder when the number is divided by 3 by 2 or 3, or when it is divided by 5 by 2 or 5, or when it is divided by 7 by 2 or 7, because in each case these remainders are smaller than the factors of the original numbers, right? So if we see here properly, the difference between 1.5 and 1 is 0.5, and here also the difference is 0.5, and the difference between 3.5 and 3 is also 0.5. So we can see the difference over here between divisor and the remainders are constant. So the number which we are talking about, the smallest number, which when divided by 3, 5 and 7 leaves remainder 1, 2 and 3 respectively, will actually be the LCM of 3 by 2, 5 by 2, 7 by 2 minus 0.5. So now we can solve it, and that number will be LCM of 3 by 2, 5 by 2 and 7 by 2 minus 0.5. And the LCM of the fraction can be written as LCM of numerators, which are 3, 5 and 7 in this case, divided by HCF of the denominators, which are all 2 in this case, minus 0.5, and LCM of 3, 5 and 7 will actually be the product of all these numbers, because all of them are prime numbers, divided by HCF of 2, 2 and 2 will be 2, minus 0.5. 5 3s are 15, 15 multiplied by 7 is 105, by 2 minus 0.5 can be written as it is. 2 1s are 2, 2 5s are 10, 2 2s are 4.5, so this is 52.5, and minus 0.5 will give you 52. So 52 should be the number which is when divided by 3 gives the remainder 1, and when divided by 5 gives the remainder as 2, and when it is divided by 7 you get the remainder as 3. So let's check it. When I divide 52 by 3, 3 ones are 3, 5 minus 3 gives you 2, and let me note down this 2. 3 sevens are 21, 2 minus 1 is 1, and this is 0. So we are getting remainder 1. And let's check by dividing 5 also. 5 ones are 5. If I subtract, I'll get 0, and let me note down this 2. 2 will be divisible 0 times, and I get remainder as 2. And when I divide this 52 by 7, 7 sevens are 49, and the remainder we get is 3. So this actually satisfies all the given conditions. So 52 will be the smallest number which we are talking about. So that's all for this video, and in the next video I am going to take few more similar kind of problems. So keep watching MathSmart, and bye bye till then.